Hi everyone, this is Kalpana from Department of Chemical Engineering, Hindustan College of Engineering and Technology. Here we are going to discuss about safety in chemical industries. So the topic is risk due to radiation. So we all know that the radiation is the most hazardous thing if it exceeds its limit per day. So let us see what are the risks and what are the preventive measures that are available to take care about the radiation effect. So first is, what is radiation? So radiation is the energy which is transmitted by the particles or electromagnetic waves. Radiation can be ionizing or non-ionizing depending upon their characteristics. So let us see the different types of ionizing and non-ionizing zone of radiation. So here see in the right side, it is the ionizing radiation. It is the most of the 95% of the ultraviolet light comes under ionizing radiation. Then X-rays, gamma rays, then damages DNA. So these are here in the bottom they have given the effects, that is damages the DNA. For example, it is medical X-ray. So when it exceeds the limit to be absorbed by our skin, it may damage our DNA. Then non-ionizing radiation, they are being classified into three different types according to their intensity. First we can see from the right to left, we can see the visible light where it excites electrons, it causes photochemical effect. Heat lamp and tanning booth are some of the examples. Then microwave radiation, it comes under radio and infrared region. So it can cause thermal effect, that is microwave oven, AM radio, FM radio, TV, they all come under microwaves. Then extremely low frequency, it is non-thermal radiation. It induces low currents, that is static field, power line, they are all comes under non-thermal effects of non-ionizing radiation. Then it is about radio frequency radiation. So the wavelength of radio frequency radiation is greater than 1 meter. As you can see in this image, it is greater than 1 meter. Then gamma rays ranges from 10 power minus 11 to minus 9. Then X-rays minus 7 to minus 9. As you can see, UV ranges from 10 power minus 5 to 10 power minus 7. And visible region, it holds the very smallest thing. Then infrared, it is from 10 power minus 2 to 10 power minus 4.5 or 4.3 something. Then microwave, it is 10 to 10 power minus 2. Then radio wave, you can see it is in the positive region, that is 10 to 10 power 3. So these are the wavelength that can be holded by these ionizing and non-ionizing radiations. Then it is about microwave radiation. Microwave radiation has many uses including cellular phones, highway speed control and food preparation. These three are most important thing, and we can use the microwave radiation to reduce our work. But the problem is only when it exceeds the limit. So is microwave radiation dangerous? Definitely it is dangerous. So let us see. Currently exposure limits are based on preventing only the thermal effect. Further research is needed to learn more about the non-thermal effects of the microwave radiation. So let us see the laser applications. These are the application of the laser light. The consumer products such as laser pointers, printers, CD players, they all comes under their applications. In eye surgery, so especially for eye surgery nowadays laser application plays a major role. Then in industry we can use it for welding, cutting, all those things. It can be easier through laser light. Then these are the general laser safety to be followed, such as wear appropriate protective eyewear, use minimum power or energy which is required for the project, then reduce the laser output with shutters or attenuators if possible. So we cannot avoid the laser light, but we can just reduce their exposure. So terminate laser beam with beam trap, then use diffuse reflective screens, remote viewing systems, etc. during alignment if it is possible. Then we have to remove all the unnecessary objects from the vicinity of the laser while doing the experiments. Then keep beam path away from the eye level while we are sitting or even standing. So we have to keep the beam away from our eye levels to avoid the contact with the. Then what are the emergency procedures if we are subjected to the laser beam? We have to immediately shut down the laser system, then provide for the safety of the personnel, that is first aid, CPR, etc. Then if it is necessary, we can contact the fire department, then inform the radiation safety division, and also inform the principal investigator about the emergency situation. So we should not resume the use of laser system without approval of the laser safety officer. So if we do so, we must face all the consequences. Then it is about sources of infrared light. So it is also a radiation. So any object which has a temperature above the absolute zero radiates in the infrared region. So even the object we think of being as very cold, such as an ice cube, also emit infrared light. Then what are the sources of infrared light? As we can see in this image, even human and animal emit infrared radiation. So then we can see about the visible light and infrared light. Some animals can see in the infrared region, and these images will give you a clear idea of how different the world would look if we had infrared eyes. So in the right side it is shown as infrared, and in the left side we can see the visible region. So what are the sources of UV light? So UV light is emitted naturally by the sun and the stars. It is produced artificially by electric lamps and light bulbs. So we have to be aware of that, and we have to take care of us from the UV light exposure. So is UV light dangerous? All UV light can damage skin and eyes. Overexposure can lead to sunburn and various kinds of cancers, including melanomas. It can also lead to weakening of the immune system if we are exposed to longer period of time. Then what are the protective measures? See here, it is to ensure that the skin and eyes are adequately protected. Then never look directly at the source. Operate UV lamps in light tight conditions. Also we can see about the radioactivity. Radioactivity is nothing but the natural property of certain nuclides to spontaneously emit energy in the form of ionizing radiation in an attempt to become more stable. We can see X-ray, beta ray and gamma ray. What are the types of radiation? As we have seen before, we have three different types of radiation. One is alpha, beta, gamma and neutrons. So in this image it is clearly given alpha rays cannot penetrate through skin, but beta rays can penetrate through skin, and it can also penetrate aluminum rod. Gamma rays and X-rays, they can penetrate through skin, aluminum and even lead. The neutrons, it can penetrate everywhere including concrete. So the thing is, we have to be aware of the exposure limit, and we have to keep ourselves safe from all these radiations. So let us see what are the exposure limits they have given to be followed. So total effective dosage equivalent, which is indicated as TDE, sum of dose from external and internal including weighing. It must be less than or equal to 5 rem. Rem is nothing but the unit used to measure the amount of radiation. So effective dose equivalent, dose to organ or organs over 1 year period. Then total organ dose equivalent is also given, which must be less than 50 rem. And exposure to fetus during pregnancy, it is 0.5 rem in 9 months. It should not exceed more. So we have seen all the remedy measures, also what are all the effects that can cause due to both ionizing and non-ionizing radiation. Thank you.